Hello everyone. My name is Thomas Kim. Today is 3rd of April 2024. It is 1:30 p.m. In this episode, we will implement complex number class for NVIDIA CUDA compiler from my YouTube channel. If you click this link, you can visit my Korean channel. Scroll down from Functional Programming with CUDA and OpenGL. Please double-click this link. From this playlist, 006 CUDA. In my previous episode, I discussed complex derivative, CPU, or host implementation. Show more. Download current video source code. Click this link. Show in folder. Unzip it. Rename 007 derivatives. In this folder, select all, unselect CEX this folder. Also unselect complex.cpp, complex.cu, then delete. Now go up, copy the folder, paste it in your working directory. Open up Visual Studio Code, OpenGL CUDA. From folder 007, double-click complex.cu, also complex.cpp. So I opened two files. Ctrl V. I will copy and paste these links. I updated C++ library extensions right before filming my current session. If you want to try my source code on your own machine, you need up-to-date C++ library extensions. By clicking this link or this link, you can download up-to-date C++ library extensions. We created this file, complex.cu, in one of our previous episodes. We will test if this file builds successfully on our machine. Open up your command prompt. dir cd 007 derivatives dir.cu. We need this command string like this. nvcc complex.cu on.exe SED C++20 X compiler WD 4819 EXPT relaxed context for extended lambda. Hit enter. If you set your environment variables properly on your machine, you will be able to build the source code successfully on your machine. CLS N. It should build and run successfully. Please be warned in advance. I will be using C++20 concepts unsparingly, liberally, without limitations. If you are unfamiliar with C++ concepts, then from my YouTube channel, you can watch videos in this playlist, C++20 Standard Concepts. Without C++ concepts, it might be very difficult to follow my current and future sessions. For example, for the test CPP concepts, CPG display function name. This is macro. Copy the function name test CPP concepts. Paste it in the function main. Disable this part. std cout std bool alpha. Here auto I1 auto D 4.5 or C, I create an arbitrary lambda, semicolon, return ARGs. This is called fold expression. Here, type name ARG types. I will give constraints requires size of ARG types. This should be 2. Then ARG types. SED cout is I a number. Then CPT number C. This is concept. 댓글 type I. CPG and there. Copy. Paste. Is D a number? 댓글 type D. Paste. Is C a number? 댓글 type C. And there. Somewhere in my source code, I defined a concept called CPT number C. Underscore C means its concept. We will rebuild CLS and please take note. Is I a number? True. Because we defined I to be an integer. Is D a number? True. Because we defined D to be a double. Is C a number? C is lambda, not a number. So, false. Now, copy this, paste. Is I a function? CPT function C. Is D a function? CPT function C. Is C a function? CPT function C. With this, we rebuild CLS N. Because I is an integer. I is not a function, so it is false. D is a double. Is D a function? False. C is a lambda function. Is C a function? True. Now, SED vector A 1, 2, 3, 4. I will copy, paste. Is I a number or function? I will use number or function C. Is D a number or function? Number or function C. Is C a number or function? Number or function. Copy, paste. Is A number or function? A. It should be and there. We test once again. CLS N. Is I a number or function? Because I is integer. I is integer. So it is true. Is C a number or function? C is obviously function. So is true. Is A. We defined A to be a vector, a number or function. A is neither a number nor a function, so is false. These are a few concepts that we will use most frequently. Now, I introduce more advanced concepts that I will be using in the current and the near future sessions. CPG, display, function name, or I4, or D 3.5, or C. C is a simple lambda. I will use constraints all the time. ARG types. Count of ARG types are limited to 2. It can be simple fold expression. Of course, ARG types, ARGs. I will create one more lambda. This is P. Now, count of ARG types can be 3. It is now product. SED, Cout, I, D, at least 1, not a number. CPT, at least 1, not a number. We provide 댓글 type I, 댓글 type D, CPG, and there. I would change it. I and D has at least 1, not a number. Copy this function name. More advanced concepts in the function main. We revealed CLS N. Please take note. The set with elements I and D has at least 1, not a number. False, because I and D, I is an integer number, D is double number. Because all elements in this set are numbers, so has at least 1, not a number, is false. At least 1, not a number. This concept reports false. Now, copy, paste, I, D, C. Here, 댓글 type C. With this, we build again. CLS N. The set with the elements I, D, C has at least 1, not a number. True, because C, this C is not a number. So IDC has at least 1, not a number. True. Now, context per or P count of C, CPT parameter count B. 댓글 type C semicolon. Copy, paste. P count of P 댓글 type P SED Cout parameter count of C P count of C CPG and there. Copy, paste. Parameter count of P count of P and there. We rebuild CLS N. Please take note. In case of lambda C, we constrained the count of ARGs type or ARGs equal to 2. So parameter count of C is 2. In case of lambda phi, we constrained the count of ARG types or ARGs to be 3. So parameter count of P is 3. We used CPT parameter count V, this type function. Now context per or common P count CPT argument count. We provide deckel type C, deckel type P, then angle bracket. This is function. So we are providing two template argument in the function call argument count. This is function call, so we need parentheses here. I will put carriage return with this std cout common parameter count common v count cpg, and there we revealed cls n. Now the function argument count deckel type C, deckel type P. C is lambda that takes 2 parameters. P is lambda that takes 3 parameters or arguments. Common parameter count of C and P is the bigger, the greater one, 3. I'll be using at least one, not a number C, this concept. Also, parameter count V, this type function. Also, argument count, this template function. All the time when I implement C++ complex class for CUDA compiler. C++ 20 concepts bring us unprecedented computing power at our fingertips. Have an open mind and embrace this new technology. Have an open mind and embrace this new technology. Then we can enjoy unprecedented computing power.